Very much. Going to be talking about writing API extensions for Nova. Unlike all the other speakers today, I'm actually very new to the OpenStack project. Just a bit of background. I only started working on OpenStack about September, October last year, and didn't actually know much Python before working on OpenStack either. So this is a bit of a perspective for someone coming pretty new into the project. I got asked to convert some functionality which was in a command called Nova Manage, which is a command line tool to take some of those APIs which are only available through a command line tool and make them available through the standard OpenStack API. Do you want it higher? Okay. Is that better? Okay. Okay, top's a bit cut off. So why would you create an API extension? Well, it's a pretty easy way to add new features to Nova. It allows you to get it into the new features into a tree fairly quickly. It can sit there for a while, get tested, and then a decision can eventually be made whether it moves into core or not. It doesn't seem so clear at the moment, from my perspective anyway, about what's core and what's not core in Nova, and that everything seems to get shipped at the moment anyway. But that's kind of how the process works. The URL down the bottom, you can get access to documentation on all the APIs available for OpenStack. Now, it's not quite complete. When I was scoping out the work for Nova Manage, I basically based it on the information, the documentation there. And to my surprise, when I actually started implementing, I found a few of the APIs were actually there, just it hadn't made it through to the documentation yet. So I'll go through a bit about how you can help ensure when you write your own extension, making sure documentation gets through so people know how to use your extension. So just a quick summary, it's REST interface, so you have your standard HTTP verbs, you get post, delete. So an example, if you want to retrieve a list of all the extensions in Nova, you can just do a get. There's the version number of the API you're using, tenant ID and extensions, and it will give you basically a formatted list, either in XML or JSON, of all the extensions and a bit of information about them. Similarly, if you want to delete an image, you can just do a delete request to the server and it will delete an image if you pass the right image ID. So where do you start? Start with a blueprint if you want to get your code into the tree. This is how the process works. You go to the website, put information in about what you want your extension to do, general idea of how it's going to work. You can link more information to the OpenStack wiki, put the details in there, and then discuss it on OpenStack Dev, on the mailing list, and on the IRC channels. And you commonly get quite a bit of useful information back on perhaps some problems you'd find when doing it, or some updated information on how you should approach it. As far as writing the code goes, I'll just take an example from what I did from the Nova Manage work, and wanting to add an interface for managing fixed IPs. In this case, I want to be able to get information about a fixed IP. So the interface would look like a get. The OS fixed IPs is basically the name of the extension, or how you address it, and then put the IP address at the end, and it should return you information about that IP. Or you might want to reserve or set that IP address as unreserved. In that case, you do a post to that URL you can see above. You attach some JSON or XML data to your request, or whether you want to reserve it or unreserve it, and the extension needs to process it. So all your extensions go under Nova API OpenStack Compute Contrib for the Nova extensions. And in this case, it's going to be called OS fixed IPs, so the file itself is called fixed _IPs. Now, this is just a bit of a skeleton of the code itself. I guess the more important bits are about importing the extensions module from Nova. There's a bit of authentication authentication modules you need to bring in. The fixed IP controller, that's the class which will hold the bulk of the functions which manage the requests which come in. And there's a bit more framework where you actually name the extension, how it's addressed, some initialization stuff. The class naming is not your standard, I guess, the PEP8 which is used through most of the code. That's a bit different just because that's how extensions are currently detected at the moment. And it's something that we'll be trying to fix in the future, but it does look a bit odd. So just going into some of the detail, for example, if you want to implement the GET requests, this is here. Basically, if you have in this case, the GET request will map through to the show command, show function. The IP address is passed down as ID. There's just a bit there with the authorized context. That does the authentication, whether you have permission or not, the caller has permission or not to use that API. There's a few database calls, that's not so important here, but you basically create a dictionary of the data which you want to return, and the rest of the infrastructure, when you return it, looks after, in most cases, or in cases returning as JSON data, most cases XML, you don't need to do any work either. It just gets returned as XML if that's what the requester wanted. Another example is the reserving, unreserving fixed IP. So in this case, the post automatically maps through to the action function. Again, there's authentication there. There's the body of the post data comes through the body dictionary. So you can have a look at that. In this case, we look to see whether it's reserve or unreserve and act on that. If it's not, then you can return, in this case, HTTP bad requests. They've obviously not understood the interface or sent bad data through. And if everything goes okay, then you can just return that, like, I think that's a 202 HTTP accepted. Generalizing it a bit more, the different HTTP verbs to what it maps to what function will be called within your class. So posts will end up as create or actions depending on what you apply them to. Puts will map to update, get will either be a show or an index, and delete maps to delete. So another example of getting, say, for example, all the floating IPs which exist for a tenant. You can pass that get command through, and that will map through to index. In this case, there's no parameters, so you don't need to. It doesn't pass anything further down. The get floating IP info basically just builds up a large dictionary, returns it, and again the infrastructure just handles converting it into the right format. So that's basically the bulk of the extension or the code work that you need to do, but there's a bunch of stuff that you need to do around it to get it through the system. There's some policy files which define who can access the API by default. This is an example of the floating IPs bulk extension. In this case, just defining that you need to have admin privileges in order to be able to access it. Also, to run the unit tests, you need to edit another policy file which is used just for the tests themselves. In that case, you don't need to do any restrictions for it, but it does need to exist. Otherwise, your unit tests won't work. If you're submitting a patch, you definitely want to submit unit tests at the same time. Again, tests go in, they've got a special directory to put all the tests into for extensions. This is just a bit of an excerpt of the floating IPs bulk unit test. So you have your standard setup and tear down. You can set up a set of, in this case, floating IPs to be used to retrieve again. But the basic thing is you do your request, check the data, and just assert that the data you get back is what you'd expect. And these unit tests will get run every time a job goes through the CI system, and so we know when there are regressions. There's a test which tests which extensions exist currently in Nova, and so to get your patch through, you'll need to add yourself to that list of extensions. There's a couple of places you need to add some JSON as well as some XML, because there's two different versions of the request. These, I'll just go, oh yeah, okay. The next bit is the generating or helping to generate documentation. It's done in a way where you almost write a test case, and it is run as a test. And what it does is just confirm that the expected output from your APIs stays consistent, or you at least need to update your tests if you're going to change it. There's the broad outline there of how you do it. You basically create any templates which you might need for JSON or XML for input for, say, post requests. You run the tests with a special environment variable set, and that will generate some new output for you. The test will fail because there's no existing output to match against, but then you can copy them back, and the next time you run it, it should succeed. You need to create both XML and JSON versions. Now, when you submit these, you should also, on your commit message, just put a doc impact flag on your commit message, and this will automatically notify the documentation team that they need to have a look at your patch when it goes through and extract the information which is generated and put that into the API doc site. And that will help keep the documentation synchronized with the what is actually implemented. Just another quick example. Again, you can see it looks very much like your standard kind of unit test. You add it to, I think on the previous page, there was a test API samples. All of these tests for the documentation go into the same file. So basically just add your class test there. There's a standard setup, tear down. This is a simple example of a get. You don't need to have any templates for any data to be sent in this case. But basically you do the same kind of thing of send the data and then, send the request, retrieve the data and just confirm that the output is expected or assert that it is. So in this case the output gets put into this special doc directory based on the name of the extension, so you have to go find that. You basically copy it, a slight renamed with adding the TPL file. Yeah, this is just an example of the format in JSON which just get returned when you do the bulk floating IP request list. So once you've copied that back, if you rerun the test, it should succeed the second time. This is an example of creating a whole lot of floating IPs at the same time using the API. In this case, you need to create a template manually, which you can see down the bottom. There's basically some parameters there which will get filled out when you actually do the request. You can see, for example, IP_range is in the template file. When you do the request, there's a dictionary there, and it basically just matches those up and does the replace. You run it the same way, it'll generate output, you copy, just make sure the output's correct, copy the output back to where it's expected in the test directory, and then the second time you run the test, it'll succeed. So that handles it for basically creating JSON data. Creating the XML tests is very easy. You just create another class which inherits off the JSON, and there's just the standard C-type equals XML, and it will automatically generate XML for you when you run the XML test. You have to do the same thing of creating any templates which you need and copying any of the output back so it has something to compare against in the future. There is one bit of a gotcha with creating new extensions, in that you can't add to existing extensions already in Nova in the same file. There's no real versioning of extensions currently in Nova, so there's no way of telling from a user point of view what functionality exists except for listing what extensions are currently supported in Nova. So if you want to add new functionality, even backwards compatible functionality, you need to create a new file, a new extension, and extend it. It gets a little bit, the code required to do that can get a little bit trickier, but there's an example there which I have if you want to have a look at the patch of how you do that. It's a bit weird, and hopefully we'll have versioning in for Nova extensions soon. So the process is not well documented. Most of what's here is basically from what I found out from looking at existing kind of extensions, asking on IRC, and basically keep submitting patches and getting feedback. I must say the OpenStack community is really, really friendly, I found. No one's been flaming me for asking stupid questions or anything like that. They've been really good with their feedback and really helpful. So if you're thinking of getting into OpenStack and writing code, I'd really encourage you to. It's a really nice community to work in. Are there any questions?
Thank you. So I have an extension and I'm planning on adding methods to it one at a time, like add a show method and then do a git review on that and then later add another method. What's the best way to handle that?
Or I guess you can just get it reviewed and just mark it as a work in progress and just ask that they don't actually accept the extension. And just work in that process and get it reviewed a few times, and then when it's all ready, and then do a git review without the work in progress and ask for it to be put in properly.
The trouble is that I'm building on an extension that already exists, so should I make a new extension, you reckon?
You're going to need to create a new extension, yes, and extend that previous extension. It's a real pain, but that's the way to do it at the moment.
Oh man. Okay.
Anybody else? Yep. Sure.
Could you just quickly go through how to create that template JSON file again?
Is it that one there?
Yeah.
So basically it's when you design the extension, you'll know what format you want your JSON data in. So you basically write it as if it was a real request, but where you have variable data which you may want to change in the actual test, you have this percent curly brackets and then the name. And then if you look, I don't know whether you can see the mouse pointer or not, but if you look up in the dictionary in the self do post, there's, for example, IP_range, and so down below in the template during the test it'll replace the IP_range bit with 192.168.1.0/24. So basically you can make your tests more flexible in that manner rather than hard coding stuff into the template itself. Okay, thank you.
Thank you.